Figure shows the forces applied on a right arm and a hand that holds 100 newtons. A. State the two conditions required for the equilibrium of a body acted upon by a number of forces. A direct question that depends on how much you studied the lecture of moments. The two conditions of equilibrium are resultant force equals 0 and resultant moments equals 0. The mark scheme also gives other options for the answer. You can say no resultant force acts. You also can say no net force acts. Or in another form, you can say the total force upwards equals the total force downwards. Another form is the total force in any direction equals the total force in the opposite direction. The expressions the sum of forces, resultant force, and the total force all give the same meaning. Number 2, you can say no resultant moment. You can say no couple or no torque acts. You can also say sum of clockwise moments equals the sum of anti-clockwise moments. These are several meanings for the same expression. Question B. The 25 newtons force in the figure is the weight of the forearm acting at its center of mass. F is the force in the biceps muscle of the upper arm. P is the point in the elbow about which the arm pivots. The distances of the forces from point P are shown. I, by taking moments about point P, calculate the force F. The force F is calculated using the second condition of equilibrium. The total anti-clockwise moment equals the total clockwise moment about our pivot, which is P. In this question, two forces will cause an anti-clockwise moment, the 100 newtons and the 25 newtons. So we can say that 100 times 35. 35 is the distance between 100 newtons and the pivot P. If we add this to 25 times 16, 16 is the distance between 25 newtons and the pivot P. All these will give the total anti-clockwise moment. Actually, this must equal F times 3 centimeters. F is the force of the biceps, 3 is the distance to the pivot. By calculating this, you will find that the force F in the biceps equals 1,300 newtons. Question II. A force acts on the forearm at point P. Calculate this force and state its direction. If we draw a diagram for the forces on the forearm, we will find that 100 newtons downwards and 25 newtons downwards are opposed by 1,300 newtons upwards. But wait a minute, it's clear that there is a missing force, because the first condition of equilibrium is that the total force upwards must equal the total force downwards. This missing force is always at the pivot, because it does not cause any rotation, it does not cause any moment. But how much is this force? Applying our rules, this force must be 1,300 newtons minus 100 newtons, which is downwards, minus 25 newtons, which is also downwards. So our force will be 1,175 newtons, and it must be downwards. Now and only now, we can say that the arm is at equilibrium.